Okay, well, we're going to get going. I think you'll figure it out. You be okay? Alright. So today, I'm going to talk about a couple different things. We're talking about finding solutions to quadratic functions and performing operations on those solutions. So this is basically what we did day one. And then we're going to do some operations with those solutions. And then we're going to change between the two forms. Vertex to standard, standard to vertex. Vertex to standard you'll be able to do in your sleep right away. You'll know how to do it. It'll be great. Standard to vertex will be a little more difficult, but I think it'll be okay. Alright? So, first and foremost, find the sum of the solutions of the following equations. So what is that telling me to do? Add, right? So it's telling me to add the solutions of the equations. So first what we should do is we should probably find those solutions, right? So going back to day one, put in reverse for a second. That first one, x minus 3 squared minus 25 equals 0. Remember we had two methods. We could either get one side equal to 0 and factor it, or we could get a squared term all by itself and take the square root. Which one is this going to be? The second one, get the squared term all by itself, right? So let's do that. Let's add 25 to both sides. X minus 3 squared equals 25. Okay, we said once you got that squared term by itself, we're taking the square root. Well, I get x minus 3 equals 5, and x minus 3 equals negative 5. I need both of those, remember. When we are solving equations in quadratics, we should have two solutions 99% of the time. Well, find our solutions. Plus 3, I get x equals 8, plus 3, x equals negative 2. So those are my solutions. Put a circle around them, call it a day. No, we got to add them, right? It said what's the sum? The sum of the solutions. So just take 8 plus negative 2 gives me 6. Pretty easy, right?
X equals 6, or do you just put 6?
Just put 6. Okay? So it's really what we're doing day one, just kind of getting a little refresher on it and mixing it up a little bit. So the second one, x squared plus 6x minus 27 equals 0. This is one of those where we want to get the squared term by itself, or we want to get one side equal to 0.
One side equal to 0.
One side equal to 0, good. Then, Ange, what do I do once I have the one side equal to 0?
You factor.
Factor, my second favorite F word. Behind FOIL, obviously.
Oh.
Good one, 0. God. All right, you want to multiply to negative 27, add to 6. What are we looking at? Negative 3 and 9. So x minus 3, x plus 9. Okay? Hey, guys, once we get to here, we want to separate them, right? Does anyone remember the property that allows us to separate them? Yes, but what property tells us we can do that?
Something is 0.
Where is it? 0 equals distributive. I can't find it.
What's happening between these two?
Multiplication of 0.
So the 0, hey, what do you call the answer of multiplication? Product. The 0 product property, right? If anything times 0 is going to equal 0. So take each of these like Anne said, set them equal to 0. Add 3. X equals 3 minus 9. X equals negative 9. And once again, we want the sum, so we're going to add them together. 3 plus negative 9 is negative 6. So just make sure you're careful when you're reading directions. It might not just ask you for the solutions. It might also ask you for like the sum of the solutions, or the difference, or the product, right? Just be careful reading directions. Hey, what were those other keywords we talked about that meant the same as solutions? Roots and zeros. Good.
No.
Alright, any questions?
No.
Okay, let's keep going. Changing forms, vertex to standard. This is a really, really easy one. When I square something, what does that mean? So if I say 2 squared, what does that mean? Multiply it by itself. So when I have a square term in this vertex form, and I want to change it to standard form, I'm going to write it out like I'm multiplying it by itself. X minus 2 times x minus 2 plus 5. Well, what do you think we're going to do? Why do you think we did that? Ange?
The square.
So because of squared we did that, yes, but what are we going to do now that we've done that? Why do you think I would want them next to each other? The FOIL, right? My first favorite F word.
Hey.
So, yes, guys, the idea here when we're going from vertex to standard is we're going to FOIL and then combine our like terms. Right? Because, hey, is it the same to FOIL as it is to just distribute the squared in here? No, do not distribute that squared. That's not what that means. Right? So let's FOIL. First, outside, inside, last. Y equals x squared minus 2x minus 2x plus 4 plus 5. We said once we FOILed, then we're going to go ahead and combine our like terms. Y equals x squared minus 4x plus 9. Well, hold on a minute. Look at that.
Wait, what?
What is that? That's standard form.
Whoa.
I'm done. That's it. That's all I had to do.
Oh.
That's literally all it was. You go from vertex to standard. That's all you have to do. FOIL and combine your like terms. Super easy. All right, let's try another one together. Y equals x plus 1 times x plus 1 minus 6. Well, if I FOIL this, I get y equals x squared plus 1x plus 1x plus 1 minus 6. So I FOIL, now I'm going to combine my like terms. Y equals x squared plus 2x minus 5. It happened again. It's in standard form already. Oh, how nice is that? That's pretty neat. All right, try the third one, please. Kenzie, pick a number. You are Kenzie, correct? 16.
Horses there, buckaroo.
Okay, thank you. Well, I'm not going to tell you who it is for a second because then people stop doing it.
Oh.
Right?
Ah, smart.
I was in high school at one point. I do know what happens.
You had childhood?
Believe it or not, yeah, I was only like
Surprisingly.
8 years ago.
Oh, that's weird.
7 years ago, yeah.
Oh,
Oh, no, 8 years ago. I graduated 8 years ago.
wait, wow. That's crazy. Yeah, I have brothers over there.
What does it mean, please? Gosh.
Oh, that is weird.
Hey guys, how we doing?
That's weird.
We're good? We ready to go?
My mom was 40.
Alright, Renee,
Oh my god.
I'm bored. Yep.
Yeah, it always do.
You can blame Kenzie, she picked you.
What's your grandma's? What?
That's why I can't find that.
That was beautiful. I'm a literary prodigy.
Sweet, thank you. Yep. Hey guys, we all get that? Yeah? Okay, are we good at this? Alright, let's keep moving then. Good, thank you, Renee. So, shh, reel it back in. So that was changing from vertex to standard. To go the other way, standard to vertex, we're going to do something called completing the square. Have any of you heard that before? So completing the square. What that means is we're starting in standard form. We want to make it so it looks something like this, because that's part of vertex, right? X plus 3 squared. Now what's going to happen is we're not always given nice numbers to where it works out like that. So we're going to complete the square. We're going to figure out how we can make it be a nice number like that so it factors nicely. Okay? So that's basically what we're going to do. So, to do that, we're going to figure something out. Let's think about this. Let's look at these three here. Is there any pattern you can see between them, the equations on the right, and what they equal? Renee?
They're multiples? Like the,
What do you mean by that?
or like they're factors, like 3 is a factor of 4. 4 is a factor of 8.
True. Not the pattern I'm looking for. Larson?
Times 2 and then times it by itself.
Times 2 and times it by itself. So let's think about this. If I take 6, instead of doing 3 times 2, what if I did 6 divided by 2? I get 3, right? And if I square it, I get 9. If I take 8, I divide it by 2. And I square it, I get 16. 10 divided by 2 and I square it, I get 25. That's the whole process that we're going to go through. Is we're going to take a middle number, a b term, right, from standard form, and we're going to divide it by 2 and square it so we can complete the square. Alright, so if we practice that down here, if I want you to find the missing value of these two, come on, let's go. Here we go. X squared plus 16x plus what? And do you have a question or you?
No, I have it.
What's the answer?
64.
How'd you get that?
8 and 8.
Right? 16 divided by 2 gave us 8, and we squared it and got 64.
100,000.
Yes, Johnny?
I got the second one.
What's the second one?
100.
Very good, right? Take negative 20. Divide it by 2. Get negative 10, we square it, we get 100. Good. Does that make sense? So that's how we're going to complete the square in a second. Alright? Okay, so when we are going, what just happened? Did I go backwards? Why is that what I do? Alright, so here's our steps. We're going to divide the b term by 2. We're going to square the number. We're going to add that number and subtract it. Now, I like to do a step before all that. The first step you should do if you're changing it from standard to vertex, the first thing you should do with every problem is rewrite it. I'm going to show you how to rewrite it so it's nice and easy. We're going to take and we're going to put the x squared and the x term in parentheses. X squared plus 8x, and I'm going to leave a blank here. So I'm going to put a parenthesis over here, and then add 33 on the outside. Because my equation hasn't changed yet, has it? I just changed how it looks, right? Okay, so now here's where completing the square is going to come in. We're going to take our b term, our 8, and we're going to divide by 2. We get 4. Right? We just did that. And then if I square it, I get 16. I'm going to add that on the inside because that's going to be a nice thing to factor, right? It's going to come out to x plus 4, x plus 4. It's going to be great. But if I add it on the inside, I have to subtract it on the outside. Because I don't want to change the equation at all. Right? If I do that, I'm basically adding 0 to it. 16 minus 16 is 0. I don't want to change the equation, I just want to change its appearance. Alright, does that make sense? Okay, and?
If you don't want to change the equation, why do that?
Well, because we're trying to change forms. We're trying to get it so it's perfect in here to factor into 2 of the same pieces. If I factor from the beginning, it doesn't factor into 2 pieces that are the exact same. Okay? So when we're trying to complete the square, we don't want to change the equation, we just want to change how it looks. Okay? So if I factor this, I get y equals x plus 4 plus 17, right? I combine those like terms. Well, x plus 4 I can rewrite as x plus 4 squared plus 17. Well, hold on a minute. What does that look like? That's vertex form. We're done. Crazy.
That's it?
That's it.
Oh, I get it. Okay.
That's not so bad, is it? Do we have any questions on that?
4 plus 4 is 8.
Okay, let's do another one together. We will in a second. Just relax.
Very confusing.
So the next one, same thing. Rewrite it first. F of x equals x squared minus 16x. Leave a space. Plus 74. Okay, I'm going to complete the square. I'm taking my b term, negative 16. I'm dividing it by 2. I get negative 8. Squaring that, I get positive 64. I add it on the inside. Subtract it on the outside. Whatever I add inside, I must subtract on the outside. Alright? Well, then if I go to factor this, what does this factor to? You guys wanna know a trick? Because it's gonna factor the same thing, right? It should. It will always factor to whatever number you got when you divide it by 2. If you look in the first problem, we got 4, there's x plus 4 and x plus 4. Down here, it's going to be x minus 8, and then plus 10. So it's a little trick. If you can't figure it out, look what divided by 2. Okay? So then f of x equals x minus 8 squared plus 10.
That's not bad.
That's in vertex form. Alright? Where are we at here? What we got left?
What about if it's like not
2 more
one?
questions.
2 more questions.
Like A is not one. That's a good question.
Okay, here's what I want. Right now, I just want you to try changing it. Don't worry about the graphing, just change both of them. If we have time, we'll maybe do one of the graphing. Okay? So I just want you to change both of them into vertex form, please. If you have questions, please raise your hand. I'm more than happy to help you. But just work on changing them right now. Remember guys, once we get our final answer, it should be in the form a times x minus h squared plus k. And we want to condense it down into that one term squared plus k. Yes, ma'am? But if I foil this, the answer is
No, this is
negative 8 times positive 8. We'll hit the x minus 8. We'll hit the x minus 3. So then you should carefully factor. Okay? How you guys doing? Any questions? No, I'm doing great. Okay. How do you, ma'am? No.
You do? I don't read columns.
Do you good?
No, I just so busy doing 6th grade.
Oh my gosh,
I'll do
I
that
read
too.
that off. Did you read it?
I'm
Did you make it sound a little like that?
How do you do?
Did you read the No. It's a little. It's a little. Oh my gosh, yeah. You know what? I was called the little bird. Yeah.
Guys, check your answers, please. Take a look at them. One thing I will say, I know I've been walking around a little bit. I did notice a lot of people aren't making it an equation. What does it need to have to be an equation? Equals something, right? Equals f of x, equals y. Right? You need to have that on there. It needs to be an equation. Alright. How did we do? Good, so-so. Do we want to practice graphing?
No.
Or would you rather have work time? I think let me check. I think there should be some on it.
Like for the second one, does it matter what side the x is on?
There's graphing practice on the homework. Sorry, what's that?
Does it matter what side the
No.
x is on?
Doesn't matter which side f of x is on, doesn't matter which side y is on, as long as it equals one of them. Alright, any questions? Sweet, subscribe, swipe up.